Okay guys, I just want to have a quick chat about surface area to volume ratio. It's really scary as a phrase, isn't it? Because it's quite difficult to understand, but hopefully we're going to make it really simple. The first thing to say is that you have to understand that at the beginning of the world there were little unicellular, which means one cell, big organisms, and they had to absorb everything they got from the outside. So if the whole of their surface area was in contact with the outside, then they would be able to absorb all that they needed that could get all the way to all the parts of the cell. So, for example, excuse me, I've got a cough. If you take this piece of toilet tissue, okay, can you imagine that being an early cell? Look how much of its surface is in contact with the outside if this was, say, in a pool of water. Only the very, very small breadth of it inside is not in contact. And so most of this is surface area. So it's got a really high surface area to volume ratio. If I scrunch it up into a ball, now look at this. Most of it is not surface area. Most of it is in fact inside the ball. So the actual contact with the outside world is small. And so therefore it's got a very low surface area to volume ratio. Most of its volume is not surface area. So how would this absorb something compared to this? Well, the answer's simple. If we take some water, similar amounts, and we want to see which is going to mop up quickest, when we put that down and that down, instantaneous, that one is still absorbing. And in life, that makes a real difference because you haven't got time for things to diffuse. Things will diffuse very slowly. If we relied upon diffusion to our brains for oxygen from the lungs, it would take about 3 years to get there, literally. And so what we need to do is, if you have more than one cell, multicellular, and nutrients like oxygen and glucose have got to get to those cells, we need a transport system. So diffusion is fine for those cells which have a very high surface area to volume ratio. But as soon as you have cells which can't be bathed in the nutrients through which diffusion, simple diffusion would work, you need then to have a transport system. Okay? So high surface area to volume ratio is really good for absorbing. You can think about this in a number of ways that exist in biology. The first is lungs with alveoli, massive surface area. Kidneys, massive surface area. The example came up in the exam question of Indian elephant's ears to lose heat. Big surface area can lose the heat. So, surface area to volume ratio,